Talk about a boat anchor. Well, if it works, this is going to have to sit on the floor down below here somewhere. Probably should get rid of my Tote and Show VHS and 5-inch color TV thing here that I bought at the art sale a number of years back, and probably put it down there. If this works out, my intention of getting this, before we even try it out now, you might say, well, why would you need a power supply this big? Well, eventually, when I ever get any extra cash that I can manage to save up, I want to get a 2-meter and 440 mobile rig that'll put out at least 30 to 50 watts. And you're going to need a power supply that will run it. This will run it, but it's not regulated. This is, I believe, 10 amps at 12 volts, which is not going to be enough for a 2-meter rig, or 20 amps at 6 volts. Now, I bought this. I probably never did a video on it, but you've probably seen it on my videos, off of eBay, and I put new binding posts on it. It's not regulated, and this variac was very erratic until I put in some deoxit, and it's been perfect since. I put a new pilot light in, a new fuse holder, and it puts out good voltage. And the reason I wanted this originally, because this will do 6 or 12 volts, as I said, and if you ever get an old auto radio, a vintage car radio, most of those run on 6 volts, the real old ones, and have vibrators in them. This is what you want to use. But in the future, and it may not ever happen because they go for big bucks on the ham radio auction. They go for $150 to $200, and it's got to have the PL board to hit the repeaters. And then I got to put an outside antenna on this because the Bofang, we've got a repeater 7 miles from here, and I can't even hit it with that. I just can't. I can receive them staticky, but I cannot hit the repeaters at all. But that's my intention for the future. Now, like I say, a couple weeks ago, the guy wanted $50 firm for this. I'm taking the chance at 20. It's like, it's in mint condition as far as cosmetics are concerned. My concern is the power transformer. Like, the part of the primary was open on that battery charger, and that's why it wouldn't work on the 2-amp function, but would work on the high current part. Now, if the power transformer is gone in this, and it would usually be the primary, not the secondary, because the secondary is very, very heavy wire. If the primary is burnt out on this, I am SOL in big letters. And you know what that means. But there's only one way to find out. So that's why I got this. This can sit on the floor, under the bench, out of the way. What I want to do, and I don't even know if it has a fuse in it. It has a plus and a minus. Let's see if it's got a fuse in the front. Okay, it's a Tripp-Lite PR-60, 60 amp. See if it's got a fuse in it. It might not. It does. I don't like the looks of that. It's not blown. I'm going to put this under the eye lobe. That looks like a 30 amp fuse. I hope it's not a 30. Okay, it calls for a 15 amp fuse because it's a high current power supply. So this could be a 15, and it's not blown. I will check that because I'm hand holding this camera, and I don't like hand holding a video camera. But let me check and see if this is a 15 or it could be a 30. Only one way to find out. Well, it's a bus SFE20, 32 volt fuse. I had to use this eyelope here because I cannot read these fuses. I used to be able to with maybe reading glasses, but no more. At least they didn't put a 30 in it. So it's not blown, so what we're going to do, I'm going to turn it around and connect clip leads to it and put my meter on it. I'm not going to put a load on it right away. I just want to see what the voltage output is of this, if there is any at all. So the switch is off. We'll put the fuse back in. I have a 15 amp fuse, and I will put in the proper fuse in this. I'll get back to you. Well, there's no voltage output. I just did that off camera. I got my meter set. The light, the switch is off right now. The light is on. Now you can see the light is on. I guess the light stays on as long as it's plugged in. So now it is turned on. Nothing. Could be the transformer. So I'll set this on a tripod. I'll open this up off camera because this bench is very, very small here and crowded. I got to make some room, and I'm going to have to make some measurements in the transformer, and I am worried about that. There's no way I could, if the transformer is gone, you might as well just cut the cord off and throw it in the recycle bin, because you're not going to get a transformer for this. Because there's a 50% chance that the transformer could be shot in this. Alright, there she is. You get the size of that transformer. That's where your weight is. Well, it's a fantastic looking power supply. But there's a reason why somebody would sell this. Now, can you imagine me paying $50 for this 2 weeks ago if I had that kind of money? I never have that kind of money on me. Extremely rare. So if this transformer is gone, SOL, as I said. But there is a possibility, and we're going to go check the primary and stuff, but we want to just, I'm worried about that, and that's the first thing we're going to check. This is the secondary. This is your secondary here. This is a bridge rectifier. There's one here and one here, and you've got power output transistors here, and you got your electrolytics here, and you've got electrolytics here and resistors here. Before we do anything, we're going to check the primary, which is, I got to turn this around. Alright, and this is your primary side of the transformer. And this is what we're worried about. Here's your input right here. Now, there is a tap that goes off and goes over here. So I'm going to have to get the schematic of this if this transformer is good. I may still have to. I mean, I can look online. I haven't looked online yet, like for that scanner or anything yet. I just haven't even put the video together. And the one for my last 20, the Jewett City Flea Market today, by now you're watching it, of course, but I haven't, at the time I'm making this video, haven't edited that video yet. So here's your secondary output, your 13.8 volts. But let's test this. I'm almost afraid to do it, because people don't sell this stuff here, especially in this nice condition, for cheap, unless there's something wrong with it. Like with that battery charger I bought, the low amperage primary is gone, as I showed you in that video, but the high amp output primary is good. and that was a defective transformer, but nonetheless that battery charger would still work. It just won't work on the 2 amp, which is not a problem. However, on this, if this primary is open, that's it. Your goose is cooked, or my goose is cooked. So the heat sink is massive. And I guess the heatsink is just for these 2 bridge rectifiers. Now, the possibility that one or both rectifiers are bad, that could be, and probably is fixable, I'm sure. They're bolted on there. Heatsink compound. Well, let's test this. All right, this is the hot wire. This is the hot wire for the power transformer. Let's see if I can get my... All right, so we can see that. All right, I got my ohm meter in there. Let me put it on ohms here so it works better if I turn it on. All right, so we've got our ohm meter on the hot side, winding of the power transformer. Well, the best way to do that is let's just go right on the transformer itself so we don't confuse ourselves here. So we want this second terminal from the top. It's not coming off, but this one is. Oh, they both come off. They're both together. Okay. All right, they're both fixed together. Let me see now. .8 ohms. That's awful low for a primary. 0.8 ohms, that sounds like a secondary reading. But it's not open then, if I'm understanding this correctly. So you know what we're going to do now? If I got this, I couldn't get this clip lead in all the way. Let me try to probe itself. I can stick it in here better. 7/10 of an ohm. Yeah, 7/8 of an ohm. It's moving around. All right, so let's put that back. Yeah, there's only one connector on that. That goes there. And that one goes here. Okay. All right, let's shut the meter off. And try to be steady with it. That could be the voltage regulator, but boy, if that is, that's an awful small one for all this current. I don't know. But you got 2 thin wires, 2 blue thin wires going to a plug here that comes on the transformer here. I'm getting 1.2 volts across this. Nothing from here to here or from here to here. And this wire just goes down to one of the boards. I didn't get any DC resistance on electrolytics, but I didn't go all the way back in there to check. It's beginning to look like the damn transformer's open. And that would be my luck, you know. That would be my luck. Because if the voltage regulator was open, you won't get anything out here, but you should get something before the voltage regulator. All right, you see this rectifier here, the bridge rectifier, there's 2 of them. There's one here and one here. Now you see the 2 blue wires are AC, okay? And the symbols, you can see the squiggly line, that's AC. All right, here is a plus right here. All right, right here where I'm touching the light. But on the other side of the rectifier, and I showed you on this one because they're both the same, it shows a plus. So we got two pluses coming out of here. And we got two pluses coming out of this one. Where is the minus? Okay, I looked it up under the microscope, iLope, 2N3771 are these transistors, leastwise these two here. Now if you look at this rectifier, you see that? See that other plus over there? And then the... I can't tell what that is. Yeah, AC side, see where it says AC on the right side, the blue wire? Okay, I understand that. But we've got a plus here, and over here, I don't know if I'm in camera or not, I can't see. The viewfinder's facing the outside of the bench. I don't know if you can see that, I don't really know. Okay. Very at a disadvantage trying to get videos of this stuff. 90% of my time is trying to show you on the camera. Alright, there's a plus on each side. That don't make sense. See how these terminals are here? Okay? You've got two black wires that go in, heat shrunk, and they're rigid into here. Okay? You've got two blue wires that are rigid going into here. Now, I don't know whether it's electrically connected to this or not. I don't know. And then you've got two that go in here. So, I don't know what kind of wire. I got to get the schematic. There's just no two ways about it because I can't figure this thing out. And what's throwing me off is these bridge rectifiers having two positives coming out on each one. It just does not make sense. Alright, here's a little update on this here. I should have checked the obvious first. This switch here is on in the up position, which means these two lower contacts are connected together. When I took an ohm meter reading, it was open. This wire here goes from the fuse, it goes on the bottom here, and this one here goes on the center, like that. I'm not pushing them all the way in, I just want to show you. And the two neutrals, the neutral from the power cord, the white wire, is tied together on one connector, as I showed you. See, it's one connector. It just goes here, and the only purpose that serves is for the pilot light. The pilot light works in this switch. So, I'm getting 0.4 of an ohm DC resistance between the black wire and the white wire on the power transformer, and that would seem to indicate a short in the transformer, but there's nothing burnt, nothing smells, and the switch is open. So it looks to me like the power switch may be the only problem with this. Maybe that's it. Because this thing doesn't look like it was ever tampered with. Nothing seems to be disturbed in here. So, when I put a meter between these two pins, nothing. We'll flip the switch. It's off now. Nothing, of course. On is up. Nothing. And if I take the leads and touch them together, get 0.3 of an ohm. Alright, so it looks to me like the switch is probably bad. There is still a 20 amp fuse in here, it's supposed to be 15. But if I run this through my dim bulb, which will probably light up the dim bulb quite bright, because even without a load out here, there's going to be a surge. And this transformer has such a low impedance on the input, it's actually Let me take the resistance reading again and I'll show you. With the leads shorted together, we got 0.1 ohms, okay? These are good test leads. These aren't cheap, dinky, thin wires. Reading 1/10 of an ohm. I was reading 0.4 before. What I'm reading is on the neutral and on the black. If you see the black wire here, it's connected directly to the transformer, all right, which would normally go up to the switch. 1/10 of an ohm at 120 volts going in. Now, I do know that, you know, like battery chargers would have a very low DC resistance on the primary, but I've never seen a primary that low. So let me jumper these out and put a 15 amp fuse in here, and I'll be right back. All right, I've got a little piece of copper wire jumped in here. I put a 15 amp fuse in here, which is what it calls for. Now you're going to be the first, just like myself, to see. Now the way I have my dim bulb here, I have a bypass which shorts out the bulb, which is up here. But when the bypass is turned off, then we're running through the bulb. So here we go. It'll either go pop, because that DC resistance of that primary is very, very low, and that's got me concerned. Here we go. Well, we've got a bulb lit. I can't tell. I think that's a 60 or a 75. So we can put a meter across this now. I don't want to throw the bypass yet. I can't run it through my variac. That's only got a 3 amp fuse in it because it's good for 3 amps, and it's going to take supposedly 15 amps, but there's a surge. And even though there's not any load on it, it's going to take a surge because it's such a massive power supply. It's not going to be just a few milliamps. I just put a meter across here off camera, and I'm only getting about 1/10 of a volt out of here, DC. She's reading 0.111 volts DC. The clip leads. Well, are we ready to throw that switch on the bypass? Here we go. So that would mean that the power transformer is good, and that the switch was defective. Now we still got, turned the bypass off, so we're running through the dim bulb, so we obviously still got connection right here, so we didn't lose connection. Now let me throw that bypass over again and watch the meter. No. All right, well, at least we're getting, these are cold. At least we were getting something out of the transformer. Well, this is going to take a little research, and I got to still get the schematic. So, and replace this switch. It doesn't have to be a lighted switch. That's why they have this wire here, the neutrals going together like this, so that this switch can become lighted. That's how they did that, with a 120 volt probably a neon bulb in here. So we'll flip it one more time here. Turn the bypass on. I want to just see if that's going up at all. No, it only goes to 2 something, and then it goes right down. So it could be anything in there, really. So I can't do a thing without a schematic. So anyways, it looks hopeful. In the first video that is no doubt up on YouTube now, at the time I rendered and edited that video, which is my last 20, it was called, I had felt that the power transformer was bad because I made some tests in here. So obviously the transformer is not bad, at least wise I don't think it is. And there's a circuit problem in here, and it could be anything. So I will have to get, ideally, the manual, if there is a PDF manual on this. I will do that tonight if I got time. Between that and editing the video, and I haven't even had a chance to answer any comments. I've been out and busy all day today. And needless to say, nothing else got done on Uncle Dorkle. It just hasn't been any time. Alright, that's it. My batteries in the PlayTouch are about half down now, so we're going to end this video. Off camera, I'll replace this switch. I gotta look in my box and see what I have for a rocker switch. Doesn't have to be lighted. I can drill a hole and put a pilot light out here. That's not a problem. In fact, I prefer that because this don't light all that bright. Okay, so it's a little more hopeful than it was earlier in this video. Thanks for watching. And, well, at least I got something to keep me busy. Have a good night.